Hey guys, I'm a Science Potato, and today we have a Cura video on how to use support structures. So the first thing I'm going to do is load in a quick model here. So you can see we have a little support tower test. So I'm going to turn on our support material, and using just our default support options, we're going to hit slice. And we're going to take a look at it by hitting this preview button here. So now we have our G-code visualized for us, and we can see the blue that is our support structure here. So the first thing we're going to do is analyze it and determine how well it's going to actually support our part for us. So by looking in close, one of the first things we'll notice is the zigzag pattern that it uses. So you can see here our pattern is zigzag. There are quite a few patterns here, but most of them I do not suggest. Zigzag is pretty much the best one out there. So if we go to lines here, we can see that these support pillars are not actually connected to each other. So these are going to be very thin structures that are going to be very easy to fall over or fail. So that wouldn't be a good option to use. We can go through the other ones and we can see a grid here. And the issue with this grid pattern is you'll notice it is fully enclosed on all sides, turning it into a rigid box. And we don't want a firmly rigid support structure because this is going to be very difficult to remove because you can't squish it to tear those layers out. It basically has to come out as a solid unit, which isn't really going to work for a part like this. We can go to triangles, and triangles has the same issue in that it fully encloses the space. You don't want a support material that is fully enclosed on all four sides like that. Concentric does the same thing as well, and then it fully encloses the spaces and puts smaller fully enclosed spaces inside. But if we go to zigzag, now we can see it is not fully enclosed on all sides. There are actually two sides that are left open. This is good for removing the supports, as it leaves one direction with these long walls very rigid and sturdy so that they don't fall over, but it leaves these other two directions more squishy like a spring, which makes it very easy to just squish this with your hand after it's done to tear those supports out. So the supports are much easier to remove. We can also look at the cross pattern. So we can see here this cross pattern isn't really the best for this small part, as these structures are a bit too small to really support the structure properly. But it is open on one side, so at least there's some, it's easy to compress and squeeze it and tear the supports out. And our last one is gyroid. This is just like the infill pattern that they have, but used as a support structure. But we can see here that it is not very optimal at all. We have a lot of unsupported overhangs here, which basically means our support material would need its own support material just to hold it up. So this is not going to work well at all. So that's why we always, by default, go with the zigzag pattern. As it prints nice and sturdy, it is very easy to remove afterwards. Now we want to look at the interface between the support and our part. So looking up here, we can see that these outer walls and inner walls are connected. But when we get to these two corners, we can see here that these two inner walls, as well as the end of this skin layer here, is not supported at all. Only that outer wall is. And same with over here. We can see on this side, again, only the outer wall is supported. So that's probably not going to turn out too good. So what we can do is we can rotate the infill pattern. So if we scroll down here, we can see where is the value? The support infill line directions. So by default, there's no value in there. But we can set an angle and it'll rotate that support structure to that angle. So let's try 45 degrees. Now we can see that support material has been rotated. And if we look at it from underneath, we can see that we're still not getting contact on those walls there. But on this side, we do have contact all the way across, so that's pretty good. Another issue, though, is that now the support lines are going parallel to our skin layers. So each support line is only holding up the one single layer that is being printed above it. And that's not good. That means all these open skin layers here are not being supported at all. So that's not really good either. So how about we rotate this another 90 degrees so that it's perpendicular with these skin layers. So we'll change this 45 to 135 degrees. There, now we can see our support lines are perpendicular to our skin layers, which means they'll be much more supported, which is what we want. Now we can look and see we still have an unsupported edge here, but this edge is now much more nicely supported. So what we can do is we can try moving our part. As we move our part around the build plate, this grid's location will not change. So if I click on the part, click on my arrow here, and I'll move it over just a little bit. I moved it over about 1 millimeter. So now we can see that this is much more supported right on the corner there, which is where it's important. Now there is a bit of unsupported areas right here at the corner, but we do have this one support line coming across here, which should provide the support we need. This is a very small unsupported area. So while it's not optimal that these corners here are unsupported, this one line coming across here should provide the support we need to get a good print. And now that this line here is connecting almost right to the corner there, we know this will be good as well. But if we want, we can move it over just a hair more. There, now it's exactly on the corner. Although we can see this one is now more unsupported. So what else can we change? Well, we have our support density here. By default, we use a 15% density, but let's try going up to 25%. That's usually on the high end of support densities. I don't recommend using higher than that, but you can if you need to. So now we can see this little corner is still unsupported, but this support line has been brought much closer to that corner, so that should help as well. We can see that corner is still supported well. We got this corner here. Looks like it's got good support, as does this corner here. So now we should have good support on this flat face, and these should be nice, well-placed supports. So we can be pretty confident in this print now. But a few other things we should look at is our support overhang angle. We can see it's set to 80 degrees. So if we look at our model here, we can see the angle of these faces, and we go from 75 degrees at the highest right to a flat 90. So that means with our overhang angle set to 80 degrees, it's only going to support an angle of 80 degrees or higher. And that's why it does not support this 75 degree overhang, only this 90, because 75 is less than 80. So if we put this to say 65, now we can see that support going much lower. And even though this one angle here says 60 degrees, and ours is set to 65, it still seems to be supporting it somewhat. This outer edge has support, but the rest inside there does not. But how do you determine at what angle your part needs supports? Well, the first thing we'll do is hide our support materials so we can look at this part clearly. So here's the trick to determining if a part needs support or not. You want to look at your part from underneath, just like I am, and you want to look at these outer walls. If we zoom in real close here, we can see how these outer walls are all nice and perfectly red. But then we get to here, and we can see a bit of green peeking out, and here we've got much more. We can see both the two inner walls peeking out from below the layer beneath it. And that's how we determine if we need support or not. Seeing these inner walls here means that not only are these inner walls unsupported, but this outer wall is also completely unsupported. Same with this area here. While this area isn't that bad, we probably could get away with no support, we still can see that our outer walls are mostly unsupported here. So what can we do to improve our printer's ability to print without support? Well, we could tweak our settings to make these green inner walls disappear behind our outer walls. And how would we do that? Well, if we consider our layer height and our line width, right now we have a 0.3 layer height. So that's pretty tall. So that means each layer over is quite a far step. And that's why these layers are such a huge gap here, because our layer height's so tall. What if we used a 0.2 millimeter layer height instead? Now we can see on the 60-degree overhang here, all the green is gone. So we know we can print pretty much perfectly the 60-degree overhang with no support. But up on the 75-degree overhang, there's still a lot of that inner wall sticking out, and so it's probably not going to print too well. But it's better, and that's good. So we could go down to a 0.1 mil layer height. And now we can see all that green is gone. We got perfect red walls. This should print pretty good. Now the issue is still going to be that once we print the 75-degree overhang, we're going to deal with cooling issues, because this cross section right here is so thin that the heat inside the plastic does not have much volume to disperse through. It would much rather disperse through this plastic than the atmosphere around it. And there's not a lot of volume of plastic here to disperse that heat. So you're going to have cooling issues that may look like support issues. But putting support here can prevent the drooping caused by the heat buildup. You can also tweak your walls, your infill, stuff like that, how fast you're going, things like that, to help improve your ability to print overhangs without support. That mainly focuses on dissipating heat as much as possible. There are a few other things we can do. Say we don't want to print at a 0.1 layer height because that print would take forever. We can do other things that will improve the quality of our overhangs while actually speeding up the print rather than slowing it down. So by reducing our layer height, we reduced our step over length, which smoothed out these curves so they print easier. We can also increase our line width rather than increasing our layer height to get somewhat the same effect. So say I had a 0.8 mil nozzle and I decided to use a 1 millimeter line width. Now even though our layer height is still set to 0.3, we can see now that this 60-degree overhang, all that green is gone. And if we look at our 75-degree overhang, there's only a sliver of green actually peeking out of there. So that lets us know we can print much better with these settings as well and not need support. So I'll try reducing my layer height just a little bit. And now we can see all the green of the inner walls is gone, and we're left with just our red outer walls. Now that being said, if we slice down to here, we can see there's still so much of that 1 mil line hanging out unsupported. So we may still have a little bit of an issue here, but it's important to note that you need to sort of reality check yourself and realize that even though you're zoomed in so close, you're like, oh, look at these big lines. Really, this whole issue, the whole problem area is only 5 individual layers in size. And this is such a small part that it's not really going to be that big of a deal. You're looking at it so close here and you think, oh, it's so big, it's going to look so bad when it prints, blah, blah, blah. But in reality, this is a tiny, tiny little part, and a few seconds of cleanup is all you're going to need to make that look good. The issue arises because you're looking at it so close. And you're like, oh, it's so big and it's going to look so bad. But you got to remember, it's just a tiny little part. It's no big deal. So now we have a nice smooth red curve here. So we can probably get away with using much less support material. And this is how you check whether all parts need support material. If you're printing a huge bust of something, you can just look at it from underneath like this and determine how many inner walls you see peeking out there. We'll set our profile back to default. Another thing we can do is drag the slider from the bottom to actually cut away the bottom layers. That gives us an even better opportunity to look at it direct from underneath. So now with our default values of a 0.3 layer height and a 0.5 line width, You can see all that green that's sticking out here. So we know we're going to need support on this 75, but this 60 degree, even though there's a hair of green there, it should print fine without supports. So if we go back to our support settings, we'll turn those on. And there are a few other settings here we can go through. So you can see our support placement is set to everywhere. And that means that the support, not only will it generate on the build plate straight up, it will also generate on the part and go straight up. So if we change this from everywhere to just touching the build plate, we can see that this area of support is now gone because it cannot touch the build plate. It's stuck on the part. So that's an important setting to consider. We usually have it set to everywhere. Support wall line count, we'll put walls around the outside of your support material. But remember what I said earlier about solid blocks not being optimal as support structures. Now that wall has completely encapsulated the support structure, turning it into one rigid structure, which again is not good for having to remove that support material afterwards. So usually support wall line count, you want to keep that at 0. We can also adjust the density, which I had done earlier. 15% is our default. I'll go up to 25% if I need to, but a range of 15 to 25% is pretty good. So we can set this to 20, and we'll see that our density has increased a little bit, providing a better support structure. We can also enable a brim on our supports just to help hold them down. So now it's got more surface area. We can also set the support Z distance, which is the distance of the gap between the top of the support and the layer above it. Now you can see here that that distance is set to 0.1, but in actuality, if we look at this, it's not 0.1. The value will always be equal to at least one single layer height. We can see there's a single layer gap there, and our layer height is set to 0.3. So even though that value is set to 0.1, if my layer height is 0.3, it will only accept increments of 0.3. So I could set it to 0 for no gap, 0.3 for one gap, or 0.6 for a 2-layer gap. And that's why people printing at low layer heights like 0.1 and 0.2 have such an issue removing their support material, because that gap is so small, it's basically fusing it directly to it. But with a 0.3 mil layer height, that gap being 0.3 is much easier to remove supports, and you'll have a much easier time removing supports when you use a layer height of 0.3. You'll also have the added benefit of much faster prints as well. Last few settings are our support Z distance. So that's how far, the support X and Y distance. That's how far the support is from the sides of our part. So right now our support isn't close to any sides. Really just down here, we can see there's this little gap here between the support and the walls of this part. So if I reduce that down to 0.3, we can see that gap is smaller now. So sometimes if you have a very, very small lip, it may not generate any support at all because the support can't get that close to the wall because your XY distance is too high. So in that case, if your support is not being generated, you can reduce this value to say 0.3 or another value, which may bring the support in close enough that it can be printed on that small lip. The issue then is that this little gap may actually get smushed together by your nozzle, depending on how well tuned your printer is. So that's the downside, is the support may fuse to your part. There are a lot of other settings in the supporter we can go through, but most of them are not really important. And you can just mouse over any setting to get a description of it. Also, how we've been looking at this layer view here, if you're not sure what a setting does, you can just change the value to whatever you want, hit slice, and now we can look at it, and we can actually see what specifically was changed. There's also an enable support interface, which can be good sometimes. It's important to note by default, it enables support on the roof and the floor. So we can see there's a support structure up there, and there's one down here. Generally, I always recommend turning off floor support, unless for a specific reason you may need it, but it's going to be more of a hassle than anything. Having roof support is nice, but I would not recommend having it set to 100%. This right here is 100% solid, And that's going to cause a lot of issues trying to remove that afterwards. But we can go here and find our support interface density. And let's drop that to maybe 40%. See what that looks like. So now we have less support touching it. But if you'll notice, all of these support structures here are not connected because we're using a concentric interface pattern. We're going to want to set that to zigzag. There, now we have more of a mesh pattern, which should also be easier to remove afterwards. The one final setting I'll mention is the fan speed override. So you can adjust your fan speed when you're doing these overhangs. And generally, if you're using a lower fan speed, you'll want to increase your fan speed while doing the interface layers above your support structure. So that would be while you're printing this layer here right above your supports. The reason for that is because you want to cool these layers as fast as possible. Otherwise, they may start to merge to the support structure too much, which will make it a pain to remove afterwards. You may remove small chunks of your print if it's fused to it too much. So having a high fan speed during that time can help reduce how hard they stick together. Alright, that's my video on support structures in Cura. I hope you learned something. If you like my content, please like and subscribe, and I will be back with more videos shortly. Thanks, bye.